Welcome to this Automation World webcast focused on the connected factory and sponsored by Red Lion Controls. I'm David Greenfield, the Editor-in-Chief of Automation World. Now, of all the technological advances made over the past 2 decades, the ones that currently are having the biggest impact on manufacturing are mobile computing and industrial networking. And it's these technologies that are making the connected factory a reality for manufacturers of all sizes. Now, when I say connected factory, I'm referring to the vision of a manufacturing environment where every machine can communicate with every other machine, and operators, engineers, and plant managers walk around with handheld computers monitoring every parameter of the operation. Now, the purpose of the connected factory is, of course, to have every machine and work cell working in harmony to drive productivity and profitability across the company. Now, if you've got a pile of money in a greenfield site, there are plenty of suppliers out there who can deliver the connected factory for you. But if you're like most manufacturers, you're operating a factory that's anything but new, and it's equipped with machines that communicate via proprietary protocols and likely aren't capable of connecting to modern industrial networks. Now, the good news is that it's becoming easier to connect automation products from multiple vendors to monitor and control your assets in an affordable way without starting from scratch. Now, joining me today to explain how this is possible is Mike Granby, President of Red Lion Controls, a provider of industrial automation and networking products. Now, as a result of the company's N-Tron and 6net acquisitions, Red Lion now offers a portfolio of industrial Ethernet switches, cellular devices, and automation products to connect, monitor, and control. Now, at the end of my discussion with Mike today, we'll take your questions. But remember that you don't have to wait until the end of our discussion to submit those questions. You can enter them at any time in the webcast interface. So Mike, let's start with the phrase that was used in the promotions for this webcast, referring to the connected factory as being a, quote, brave new world. Explain why you see it that way.
Well, thank you, David. I think, as like I say, this brave new world has many names. I mean, people do talk about the connected factory where all their equipment is networked together to provide this integrated view of what's going on in the business. And you also hear people talk about the Internet of Things, where everything down to the hand dryer in the bathroom has an IP address allocated to it and is connected to some all-seeing management system that tracks its productivity and maintenance requirements. But either way, it's about getting this holistic view of what's going on in your control system and therefore within your enterprise, whether that's about a single machine across many machines or for many manufacturers these days or process companies across multiple sites.
So what are the technologies that make this possible? How can the average automation user, create a connected factory today?
Well, I think there are a few technologies. I mean, first you have the growth of TCP/IP as a common transport for industrial protocols. Now, this isn't the sort of one true network that people have foretold for decades, that we were going to have one protocol on which everything could communicate. There are too many vested interests and too much legacy equipment for anything like that to happen. But TCP/IP and Ethernet, which carries it, have provided this ability to route data across an enterprise using shared infrastructure that can also support enterprise-level communications and can thus be achieved more cost-effectively. And this simply hasn't been possible in the past. The second thing we've seen, I think, is the impact of broadband connectivity between sites, whether it's via hard links or, more importantly, for some industries at least, via cellular networks, providing high-speed links to sites where even a low bandwidth, really high latency link would have been cost prohibitive only a few years ago. And this has allowed data to be moved between locations and also enabled this entire cloud model by allowing full-time access to central storage and application servers. And of course, you have the iPad and other mobile devices and those sort of things that have untethered the operator from the control room and allowed them to roam around the plant floor while still having access to control data. Now, I think this last one is a bit of a two-edged sword from a security and safety point of view. So I don't think the control panel or the control room is going away anytime soon. But I think nonetheless you're going to see mobile devices used more and more to access diagnostic information and to get that overall view of what is happening in the business.
Well, now all this connectivity, sounds great, of course, but is this a vision that's, actually within reach of the average automation user?
Oh, absolutely. I mean, all they have to do is get a bulldozer, knock down their factory, and start again.
Well, that's a bit drastic. Is there a less dramatic option available out there?
Well, yes, but to be serious, I think there are obstacles.
Such as?
Well, you know, when you see the connected factory in a magazine or online, whether it's in ads or in editorial, you see this sort of wonderful world out there that's populated with beautiful blondes in white coats, or operated with chiseled features who are sort of running their entire factory from an iPad. And the factory is always sort of gleaming white and sparkling clean like a leftover set from 2001. And while I'm sure there are operators out there who look like Brad Pitt or Angelina Jolie, although I haven't met many of the latter, and I'm sure there are plenty of spotless factories, the real world is a lot messier than that. And I don't just mean in terms of visuals or the people. I mean, to be serious for a second, the fact is that many solutions for a connected factory work really, really well in a homogeneous environment where everything is supplied by a single vendor, or at least in a world where everything is modern enough to talk one of the few popular protocols that these systems support. But for most factories, particularly in the United States, you know, they have a hodgepodge of equipment that's been accumulated over decades. They're not about to throw all this away and replace every control system just to get into a position where they can collect the data. And the budgets simply aren't there. And more importantly, I think the appetite for disruption isn't there either. It's not that people are trying to skimp, although, you know, in some industries they operate in what a colleague of mine calls mend and make do, where, you know, each investment is really just about keeping the thing going. Even in those industries that have money to spend, the reality is that the cost-benefits analysis doesn't favor the kind of wholesale upgrade that might be required to implement these homogeneous systems.
So how do you recommend dealing with that?
Well, there's a few approaches. I mean, one is a sort of PC-based solution where you can use OPC servers that have been available for a while to collect data from all these different devices. But, you know, that does come at a price. First, you've got to buy all those software components. And more importantly, you've now got to implement a solution that's using software from at least 3 different vendors. You've got the OPC server, and maybe you've got more than one of them. You've got a SCADA or HMI package, and then, you know, the other bit, you've got the operating system. And you've also got to get hardware from somebody else. And if the whole thing doesn't want to play nicely together, where's the line of responsibility? I always remember, you know, the industrial world is incredibly risk averse. Product has to flow. Manufacturing has to continue, or people are going to hear about it. A joke I always tell to our operations people, because they like to hear it, is, you know, that we could fire all our development engineers and it would be a year till we noticed, or we could send our sales staff on vacation and maybe it'd be a few weeks before it showed in the numbers. But if the factory stops making product, and, you know, Redline Controls, we have a factory here in York, Pennsylvania, where we manufacture all our product. It's right across the road from me now. If that factory stops making product, my phone will ring in about an hour because somebody's shipment will have been delayed. It's a big deal. So, you know, no disrespect to the other functions in the business, but operations is different, has to march to a regular and unrelenting drop. So if you've got a solution that you put together piecemeal, you've got risk. And risk is very, very expensive for a business in its manufacturing facilities. And that's without even getting into the security and stability issues of a Windows-based solution. Now, again, I love Windows as much as the next guy, and our IT guys will no doubt say I love it a little bit more. But I wouldn't fly on a plane that had a flight control system that was running Windows, and I don't want people risking not their lives, nothing quite that dramatic, but their production output to software that wasn't designed for that environment. So I think more of what you're going to see is an appliance-based model where you have one box that comes from a single vendor providing the hardware and the software that you need, in this example, to connect multiple devices. And you know, we have a product called the Data Station Plus. It's not the only one out there, certainly, but I think it's a great example of this. It's an unassuming and rather unglamorous red box, but the Crimson software that it contains allows you to speak any of several hundred protocols and then move that data via another protocol or expose it via Modbus or FTP or HTTP or even squirt it up to a SQL server at the enterprise level. You know, maybe you've got a machine that doesn't speak a TCP/IP-based protocol, in which case you can use the serial ports on it to hook up to an old PLC5 that's sitting there, or even, I think we had somebody connect to an old PLC2. Or maybe you have a machine that doesn't have a PLC, or the PLC doesn't have a spare serial port. This happens with legacy equipment. Or, again, and we all know this happens, of course, never to us, but sometimes you've got a machine and the guy who programmed the PLC has been retired for 10 years and no one knows how to use the programming console, and no one's quite sure where that 5¼ inch floppy is that contains the program files, and you just can't enable the serial port. These things happen. So what's nice is you can then add data, you can then add I/O modules to our data station and monitor the production counts or machine status information directly just by counting widgets as they come off. And, you know, and it might not be pretty and it might not be Brave New World, but you'd be surprised how often that is the easiest approach. You leave what's working well in place, you don't disrupt production, and you still get all that information that you want.
And, of course, I assume you see operator panels is playing a key role in all this, too.
Well, yeah, I mean, I'm a little biased because I come from an operator panel background. I mean, I worked on the very first operator panels when men were men and they had machine interfaces, MMIs they were called then, before HMI took over. And I came straight out of high school working on those when they communicated with PLCs using parallel I/O to strobe in message numbers. And clearly they've come a long way since then. So I'm a little biased, but I think it is inarguable that operator panels are a natural nexus within the machine. Everything's to it. You have your PLCs, your drives, your temperature controllers, hopefully a couple of our panel meters, and you want all that data displayed locally on one screen for the operator to see. So once you've done this, why not leverage that box to relay the information up to a higher level system? Now, you know, we're certainly not the only people pushing this solution, but I think what's unique about Red Lion's approach is first the breadth of the driver library. You know, when we came into operator panels, we didn't have an installed base of PLCs to aim at in the same way as a Rockwell or a Schneider or a Siemens would do. So we had to be prepared to talk to anything and add new drivers to get us market access. But also, it's our software's ability to make it extremely easy to move data between devices and protocols. You know, everyone thinks their software is easy to use. I know, just like everyone thinks their kids are cute. But Crimson really does make protocol conversion as easy as drag and drop. And, you know, I think we've got further to go with this, too. I mean, with our new graphite range of HMIs, we've got I/O modules on the back. So, again, you can get to those hard-to-get data points that you want to collect the good old-fashioned way, simply by counting widgets or measuring a temperature directly. But also we have mix and match comms modules. So, you know, if you want to access Profibus and DeviceNet and something else all in the same machine, or you've got a particularly complex machine that needs a huge number of serial protocols, you can add those modules to expand and get access to whatever networks you need.
So how exactly in that kind of stuff, how do you move the data between the cells or between sites?
Well, I think, you know, within the factory, clearly, you know, Ethernet and TCP/IP, which is not to say Ethernet IP. Don't get me started on the terminological pollution that comes in there. But Ethernet and TCP/IP can already be declared the winners. I mean, we've been putting Ethernet ports on our HMIs for a long, long time. And, you know, to begin with, we were the old joke like the guy who invented the first telephone waiting for someone to invent the second one because we had nobody to talk to. But now Ethernet is pretty much the only way you're going to be moving data upwards and out into the enterprise. But it's also a way to move data around within the panel now as well, which is why so many of our HMIs have 2 Ethernet ports and 2 distinct NICs. You want to have different IPs so the address within the panel stay constant, and a single IP can be assigned to the upward-facing NIC to integrate it with a factory network without having to get those IT guys involved to allocate a bunch of addresses, or worse, prompting them to install one of those very friendly Cisco boxes that need some sort of high priest to come offer a sacrifice to it every 30 days. Now, you're also going to see Wi-Fi on the factory floor more. I still am something of a skeptic for its use in fixed installations. I think if you've got mobile devices such as automated forklifts, or you want to provide access for, you know, those beautiful people with the iPads, that's fine. For static machines, I think, except in some special cases, it's always going to be more vulnerable and less reliable than a hard link. You know, Wi-Fi is getting better all the time, certainly, and we can sell you some great Wi-Fi equipment, but the cost of running a single Ethernet drop, particularly when it can be shared between multiple protocols, is not that high. And when you can use an HMI or a data station to concentrate that information, it becomes very cost effective. So between sites, again, I think broadband is still going to be the used more and more for, used mostly for the traditional manufacturing sites. But, you know, cellular, I think, has undergoing huge growth now for distributed activities, oil extraction, things like this, or for large sites even, where the IP infrastructure isn't there, or where it's owned by IT, and you know, everything that implies in terms of getting, you know, extended sometimes.
You know, let's stay on cellular for a moment here. You know, is that a difficult technology for manufacturers to get a handle on?
It's certainly getting better. I mean, a few years ago, if you got yourself a cellular modem and a SIM card, and you'd call AT&T and you say, okay, I need a data plan, more often than not, you'd have some kid trying to sell you an iPhone because they didn't understand the pure data world. But carriers are now very, very aware of the so-called M2M market, and they see it as a great source of incremental revenue growth. I mean, every man and his kids and his dog and everybody already have an iPhone. So there's a limit to how much more activations they can get in that world. So the cellular carriers see M2M as very important, and they've got teams that now understand that industrial customer and can provide the data plans you need. But, you know, they're obviously coming at it from the thick end, and they're dealing with the larger accounts first. So there's still some difficulties at the smaller end. You know, there's lower volume users when it comes to activation. I think that's why we were so keen to acquire 6net to gain the expertise in that area. You know, we've had cellular modems as option cards for the data station, as external modems, and as option cards for the HMIs for years. But until we brought that cellular expertise in-house, they were really just accessories. Now you can offer real solutions that move the data between sites, not just some box with connectors on that we sell to somebody and they've got to kind of figure out how to bring it to life.
Now, in some discussions I've had around the use of cellular in industrial applications, there's been talk about mobile terminated data. You know, can you explain, you know, what that is exactly?
Yeah, sure. This is something that catches people out. I mean, everybody knows that if you have a cell phone, it's connected to the internet, right? You can get web pages, you can get emails, and so you get a cellular modem, and you think, well, that's connected to the internet, so my oil drilling site can now access the internet too, and it will. But what it won't allow by default is for the internet to access it. So your standard SIM card and your standard data plan will allow a machine to push its production logs to a central server using FTP or whatever, or will allow a machine to send or a drilling rig to send an SMS saying there's an issue. But what it won't allow is, for example, a web server that's running on that machine to be accessed from some other device. If you want to do that, you need what's called mobile terminated data, where the connection is initiated from the internet and terminated, hence the name, at the mobile end. And that costs money, and it brings all sorts of complications because now you've got to get IPs allocated, and you get into these things called private APNs and all these things. So it's not impossible, but again, it's one of these games that's a lot easier to play when you're a larger company and are deploying lots of nodes, and you can get somebody from the cell phone company to come in and help you. There are third-party providers who resell this service, certainly, but again, it adds complexity and it drives up the cost.
So, you know, given all these options to consider, you know, what are your recommendations for end users on how to deal with this?
Well, I think there's a technology that we refer to in-house as phone home, which I think is a much better way of going about it. So here you have a standard SIM, you have a standard data plan where you can just make connections outbound. But what happens is as soon as the cellular router powers up, it connects to the internet and it establishes a secure VPN, virtual private network tunnel, to some central server, typically owned by the customer. The customer can then initiate connections over that tunnel just as if the device was supporting mobile terminated data, and can then expose those services to the real internet if they want for other locations to access. So you get all the benefits of mobile terminated data without the costs, and you get quite a bit more too in terms of security, because the connection from the field device is now to a known server that you control on a known IP address, and you're restricting who can get in there, and you can decide who is going to get subsequent access to this data. So, you know, I think this kind of approach is going to go a lot further. Instead of, for example, you know, using this technology to access a web server that's running at that wellhead, I think what you're going to see is the web server is going to move into the cloud, and you're going to have very lightweight data transfers occurring between the server and the device, again over a secure VPN. Now, the benefits of this are huge. Not only are you not moving those web pages over what is still a relatively high cost and probably high latency cellular link, although, of course, that gets better every year, but you also simplify the management process. And management is, as this gets bigger and bigger, management becomes a more and more central problem that people have to deal with. So you've got 50 oil wells out there, and each has a web page that's serving up its status information. It's all very pretty and it's all very nice, and then the boss notices there's a spelling mistake on the page. Well, what are you going to do? You're going to fix 50 of them. So somehow you've got to update the web page on every single device you've got out there. And all right, there are ways of doing this, but it's a pain. If you have a cloud-based system, what you're going to see is that change is going to happen centrally. What is going to be going on that VPN is, as I say, lightweight data transfers. The rendering is going to be done in the cloud. And if you want to add another page or add language support because you're opening an operation in Mexico or in France or whatever, or you want to add another set of analytics, you'll do that in the cloud once, and it will effectively provide a window into all those 50 locations.
Okay. Well, on this topic, can you talk a little bit more about the management of remote devices?
Yeah, like I say, I mean, I think, management is going to become more and more important for these devices. Cellular data is used for remote access to sites, and these sites are, well, for want of a better word, remote, right? And they tend also to be numerous. So if you want to make a software update or a configuration change for this, you don't want to have a truck roll. And even if you can do it remotely, you don't want to be changing the same setting on 50 devices via some sort of web interface. Now, again, even if you've got that web interface going through the cloud and you're not worried about the latency and all these things, the fact is it's a pain to make the same change on 50 devices. But more importantly, it's very, very error prone. So if you're going in, I've got to put this configuration in this one, this configuration in that one, this configuration in the other one, somebody's going to screw up, you're going to set the IP wrong, and you're going to lose contact with it, or something horrendous is going to happen, and that truck's going to have to roll, and you've just eaten half the profits that you saved from having the cellular setup in the first place. So, one of the reasons we were so interested in the 610 acquisition is that this gave us access to some very cool technology to simplify the process. And I think we're going to put a lot more investment into this platform. Basically, you define a central configuration, you define changes that you want applied for each individual station. So it's sort of delta between these stations. And any changes you make are then pushed out automatically to all your devices out there. I mean, we talk about this always from a cellular point of view, and that's where it came from. That's where the imperative comes from, because the truck roll is such an expensive thing. But again, think about a factory where you've got 50 HMIs or 50 Ethernet switches out there, and you need to change something. I mean, that is not an unusual situation, or even take it down to half a dozen. How do you do this in a way that maintains the differences in the configuration while still allowing those changes to be applied? And more importantly, as I said earlier, how do you do this without disrupting manufacturing, without disrupting production? The product has to flow. It's vital. And I think exactly those same techniques as we're now seeing applied to cellular sites, remote sites, you'll also see applied within a factory. I mean, we've already done a test installation for a large U.S. auto manufacturer where we've taken this technology from the cellular side of the business that we acquired through 6net, and we've incorporated this into some of our N-Tron Ethernet switches so that we are able to make configuration changes to these 50 switches that are out there by editing in one place and having these changes rolled out at the right time that fits into the production schedule that avoids downtime. I think that's going to be huge. And I see our Crimson software platform that we use currently to configure our HMIs and our panel meters and our data station and our video station, sorry, our productivity station and all these things. I see us extending that platform to incorporate this technology and merging that so that we have a single platform that can manage anything from one HMI to 100 HMIs or 1,000 HMIs or 1,000 cellular modems or whatever, again, incorporating this configuration and this configuration deployment and management. Because the more systems you have, the fewer engineers you have available to do the maintenance, the more error-prone it becomes, and the more important it is to automate it to maintain that manufacturing flow.
Okay. So how do Ethernet switches and routers fit into this bigger picture then?
Well, I mean, at the most basic level, they're the glue that holds the system together. Right? I mean, you've got Ethernet, you're going to need Ethernet switches. And anything that's critical to production, again, coming back to that same thing, the product must flow, needs to have the environmental and reliability specifications that are appropriate for the shop floor or for field deployment, temperature specs, vibration, magnetic compatibility, all those things. And, that's why we bought N-Tron. Their switches are the best in the business when it comes to this. And this comes from the founder, Warren Nicholson. He was, and still is, a character. He was obsessive about quality and attention to detail. And that legacy is part of the N-Tron mindset in everybody in that business. And that is what has led to those high levels of quality and reliability and those amazing specifications. But I think it's more than a matter of competing over environmental specifications. Clearly, the product has to be fit for the environment in which it's going to be deployed. But there's also the question of what Redline refers to as industrial fluency. To what degree are your Ethernet switches industrially fluent? Can they be accessed using Modbus or SIP or some other industrial protocol rather than needing some expensive SNMP plugin for you to be able to monitor it from a SCADA package? Do they understand the subtleties of IGMP operability with Allen Bradley PLCs, which I don't, but somebody down at N-Tron does, so we have switches that are able to make that happen. Do they allow your HMI to view the status information and the performance information locally on the machine? So you can actually treat that switch as what it is, an integrated part of your control system, not some magic box that can bring down your production and get you fired, but is somehow out of your grasp. Again, the switch is part of the machine. Its status should be displayed on the machine just like anything else is. And with our switches, by incorporating this industrial fluency, by allowing them to communicate effortlessly with the HMIs, you provide that. So, you know, I think there's a clear path ahead of us on this when we look at our product roadmap with switches that provide this kind of industrial fluency and also provide security at the industrial protocol level. You know, I want to block Modbus writes. I only want to allow these things through. When you get into the switches that have greater visibility into what's going on, the layer 3 switches and the routers, and that do this not only in a way that is environmentally suited to the industrial world, that is industrially fluent, but also that is configurable and monitorable and manageable in a way that is accessible to control engineers and not just to IT professionals.
So speaking of Ethernet, you know, for the better part of the past 20 years, there's been this ongoing battle between IT and shop floor personnel, and Ethernet's often at the heart of those disagreements. Now, at some companies, I've spoke with, the battle isn't as bad as it used to be, but it still seems to persist to one degree or another. How have you seen this play out in terms of the connected factory?
Well, yes. The grand war between IT and the shop floor. I got a few little digs in against Cisco so far already, and again, that's one of those hard, only serious things. Yes, I'm ribbing them, but the fact is there is an IT way, the Cisco way of configuring switches that is incredibly powerful, but is not natural to many people. And I have a Cisco ASA sitting in my basement, and it does a great job protecting my network, and our IT guys love it because it gives me a nice secure VPN so I can work from home. But it's not what you'd call easy to use. I mean, I set it up, and despite this suave executive exterior, I'm actually something of a geek, and I thought I should be able to do it, and I should have a fighting chance at it. It's difficult, and I needed help from the IT guys. So, yeah, I mean, I think part of it is about making switches and routers that are industrially fluent and industrial aware, and that can avoid the war by avoiding having to get those IT guys involved in this level in the first place. But in the end, when it comes to IT and the shop floor, east is east and west is west, and never the twain shall meet, right? Or at least where they do meet, there's going to be some difference of opinion. When it comes down to it, IT professionals and control engineers have different backgrounds, different ways of working, and they have different requirements, and they have different imperatives, and they are judged by different metrics. So it's only natural that even with 100% good faith, and even when everyone is behaving as a completely rational actor, you're going to have different views, and you're going to have differences of opinion.
So how can this be overcome?
Well, I mean, I think the first thing is to recognize those distinct views. I mean, it's simply not reasonable to expect IT to provide an IP address for every PLC or drive in your machine or every hand dryer in the bathroom or whatever we were talking about earlier. So you use something like a data station or one of our HMIs to provide that single point of contact for the machine. So now you've got one IP address. It's all a lot more manageable, and it keeps IT comfortable. It's also not reasonable to expect IT to expose this port or that port of a PLC to the internet so somebody can configure it remotely. They don't know what that means in terms of the security of their network, and in the end, that's what they are judged on. So that's what they're going to protect most jealously. So you use the phone home technology with a wired connection, if you like, not just a cellular connection, to get that secure tunnel up and provide the access you need without giving IT a heart attack. And again, it's not reasonable to say to the IT guy, hey, I need you to run an Ethernet drop to some tank farm that's 2 miles away on the edge of the site just so you can pick up a tank level. They're not going to like that. They don't want that bit of blue wire going that far. They don't want the lightning coming in. And they don't want some port sitting out there unprotected by the fence where someone can hack their network just so you can get your tank level. Use cellular, use Wi-Fi, use a radio link. There are all sorts of technologies. So in the end, like I say, it comes down to using the technology that is available today, and that things like the data station or the HMI as a nexus model enable you to do to provide some sort of accommodation. Again, IT and the shop floor have different requirements. You have to realize that, and you have to live within those restrictions.
So given this grand view of the connected factory, how do you see Red Lion fitting into all of this?
Well, yeah, we can always sell you a panel meter, or at least that's what most people would have expected for Red Lion about 10 years ago. And just before I go on, I have to say I love panel meters dearly, and although the death of the panel meter has been predicted as, well, for as long as I can remember, I suspect we'll still be selling world-class panel meters long after you and I are gone. But, Red Lion is a bit more than that now. I mean, we're about 4 times the size that we were at the beginning of my tenure. So we doubled first by adding HMIs and protocol conversion products, and they've done very, very well for us and got us into completely new spaces. And we've doubled again recently with the N-Tron and 6NET acquisitions. It's been an exciting ride, I have to say that, and I think it's far from over. And I think what's particularly interesting is how we've been able to go from these rather humble beginnings where we actually manufactured mag pickups through panel meters and HMIs to protocol conversion, through Ethernet and cellular connectivity, and now even RTUs and I/O. And you look at the automation products and the networking products, and you see a set of tools that our customers can use to build solutions that connect, monitor, control. I mean, that's the tagline we've adopted for the company, and that's what we're all about. So, the fit of our product set to the connected factory, I think, is excellent. And I think, we've got a great story about how these products establish us as the global experts in communication monitoring and control, and how these automation and networking portfolios work better in combination and by virtue of their shared heritage. And I think, that's the most exciting thing of the company's, exciting part of the company's evolution for me, is seeing how our products, our channels, and most of all our people actually really are better together as we bring these technologies, as we bring these companies together, how our people are able to offer more solutions for our customers.
Now, following these recent acquisitions of N-Tron and 6NET, do you consider Red Lion to be well positioned to help manufacturers connect their factories today?
Well, I'm going to say yes on it, but yeah, and it's not just because we have the components and the technologies that support this vision that we're describing, but also I think because Red Lion understands the industrial world. I mean, it is a different place, and it is subject to different pressures and constraints. And it sounds a bit zen, I guess, but technology without understanding doesn't help you. It just shifts the problem. Red Lion has 40 years of heritage in this field, and we're able to take the technology, apply it in a way such that it works for industrial customers and can deliver the solutions that work within the real-world constraints in which they live.
Can you give some specific examples explaining that?
Well, I mean, I think we've covered a few already, right? So that you have the data station and its ability to collect data from just about any device out there, or even from those machines without a PLC, or from a PLC that's so locked down or forgotten about that nobody wants to touch it. You have the HMIs, which can do the same thing, act as that communication nexus in the control panel. You have the cellular routers with the phone home technology, or the remote management platform. And you can see where that's going to take us in terms of extending what has traditionally been the cellular technology to the shop floor. Or let's pick another example. So we recently launched a product called the Productivity Station, spelt in a rather strange way, as you can see, or maybe you can't see on this slide, that allows you to use our expertise in communication to collect information from your control system and display it on a large screen TV. And it's been a huge success, not only because it supports this drive to display production KPIs on the shop floor, which has been going on forever, but because the more you put this information on the shop floor, the more you have it in the operator's face, the more immediate impact you get from these management key performance indicators. But also because this is essentially an appliance. So the cost of applying this and using this product is very, very low. It's very easy to add to your factory. So again, you could do the same thing, I'm sure, with an industrial PC and a SCADA system, and you could get some I/O cards and some OPC drivers and Windows, of course, and you'd probably save a couple of bucks, right? But what you'd have is this hodgepodge of different technologies, again, that you've got to make work. What we have is a single box that does it all, and if it doesn't behave, there's a technical support team sitting, not 30 yards from me here in York, Pennsylvania, not Peggy out in wherever, but a technical support team that is co-located with the engineers that develop this product who can help you get it running. And I think, plant engineers are stretched and they're busy and they want solutions that work out of the box. They don't want parts that have to be forced together, and they don't want to have to solve problems. So I think this is a great example of that appliance model that we're going to see more and more. The Productivity Station does all that, and of course it does so with the software that we have. So again, I think it comes back to something I spoke about earlier, which is having that set of technologies, but also the heritage that drives your understanding of how those technologies are applied. Redline has both of those. I mean, we've built up a great set of products and a great team of engineers over 40 years, and they understand the connected factory because when it comes down to it, they've got the industrial controls world in their blood. I mean, I grew up visiting manufacturing plants with my dad back in England during the school holidays, back before the safety people would have a heart attack at the sight of kids climbing around gantry trains and those cranes and those sort of things. And everyone here at Redline, I think, has that same appreciation of manufacturing. So we have our own factory here, and of that industrial world, and that you can't gain that kind of insight just from a technology background or butterflying between .coms. If you take those technologies that we have and that understanding of the industrial world, I think you get something very special. And I'm really proud to be leading Redline at a time when our expertise in communication, monitoring, and control can really deliver so much value to our customers.
Well, thank you, Mike. So now we're going to turn our attention to the questions that we've been receiving from attendees while the webcast has been going on. And so I want to remind those of you out there in attendance, if you have a question for Mike and you haven't already submitted it, please do so now. Insert the question into the webcast interface, and we will get to it right now. So Mike, among some of the questions we've gotten here, one of them is basically saying, the management is wanting us to monitor our machines more closely for uptime, downtime, et cetera. And their facility, like the facilities you mentioned in your presentation, is a mishmash of vendor products. Now, they're asking, assuming your data station can communicate to their existing PLCs, is there a protocol that they should standardize on to provide to IT?
I think there's all sorts of options, and it rather depends upon what the device is that you're trying to connect to. I mean, Modbus TCP/IP never fails anybody. I mean, it's a very old, very simple protocol, but it does a great job for moving small amounts of relatively unstructured data. But again, if you're dealing with people who are less automation savvy, maybe something like pushing comma-separated variable files up to an FTP server is something that you might want to consider, or even OPCDA or something like that, or maybe even our Microsoft SQL connector, which lets you take real-time information from the shop floor and push that up into SQL. So there are lots of options. I think the key really is just to, like I said earlier, work with IT, because in the end you've only got to make one decision that you both agree with, which is what's going on there. And then by having something like the data station in the way, you can isolate IT from all that rest of the world, all the messy business of the 250 protocols or whatever it is, or the direct I/O monitoring. So work with IT, find what's best suited. I've given you a few examples of what I think would be a good place to start.
Okay. This next question is asking about moving the data up from the shop floor into the upper level systems in a standardized way, and they were asking if Redline does that through an OPC server, or, to integrate all the disparate components, and move that data up into the enterprise. How was that handled exactly? How does Redline handle that?
Well, there's several ways of doing it. I mean, we have an OPC server that you can run on your enterprise level system, and that will then talk down to the data station and provide a very simple interface whereby you can access all the tags that live in the data station. Now, if you already are running some enterprise level system that is capable of talking any one of the standard protocols that are out there, chances are we can act as a slave to that and respond to requests in that language. So again, Modbus TCP/IP, SIP, there's a huge list of them. So what I tend to recommend is, unless you particularly wish to start adding more OPC servers, just pick whatever protocol you've already got a license for and do that, and chances are you'll find we can handle it. Again, it's a little bit different if you're talking about historical data or events or things like this, but assuming we're just talking about data, we're just talking about real-time data that you want to pull across, OPC is one way to go, or just use whatever protocol you're already using, and chances are we can talk it as a slave.
Okay. Now this next question is asking about moving towards cloud-based management of the systems, and so they're asking about the Crimson product that you offer, and they're asking if there's a general timeline for implementation of that. I mean, I'm sure the answer is probably it depends on how big the deployment, but is there some sort of average timeline or expectation for how long this takes to move towards the cloud state?
Well, it could be that they're asking, there's two possible questions there, right? One, how long would it take in an instance to configure that? And the second one, I suspect, is, when will we get to the point where Crimson is able to support those facilities? Because at the moment, those are facilities that are in the 6net software that we acquired, and we're migrating them into Crimson. I think it's a matter of, I have to be careful because, my door will likely burst open at any moment, and our engineering director will come in with a baseball bat and start beating it if I start making commitments as to time. But since I think he's out of town right now, I think you're not going to see it this year, but I think by next year that's something we want to be promoting.
Okay. Now this one is asking about, they're saying they're getting a lot of demands to track energy data as well as the data from the production systems as well. And they're asking if you have any plans to combine collecting factory information with energy information in your systems.
Well, yeah, we have drivers that talk to all sorts of stuff. I mean, for example, BACnet is a protocol we do very well on, both, as a master, so we can go out there and interrogate building management devices such as energy meters and things like this using BACnet, and then make that information available on industrial protocols. So that would be an ideal way of doing that. Or alternatively, in the opposite direction, where you've got people who are using industrial control technologies in a boiler or in an HVAC system, a variable frequency drive, and they want to integrate that with BACnet. So yeah, we've done a lot of work integrating those energy and building management systems with the industrial side. And again, I think that's one of those interesting divisions that exists by purely historical reasons, that these two worlds have grown up independently and yet solve so many of the same problems, and there are so few good technologies to bridge the two. Now, we're constantly adding other protocols. If there's some fancy little gauge that somebody needs a serial or Ethernet protocol to, we do a pretty good job of adding those fairly recently. And also one thing we provide is a scripting language within our operator panels and within the data station and within the productivity station that will allow you to write very simple protocols yourself. Now again, that's not for everybody, right? But if you've got that particularly strange oddball thing that you can never persuade anybody to talk to, you've still got those options.
Okay. Now this next one is asking about the phone home product that you offer, and they're asking for more specifics on how the phone home VPN connection is set up and what equipment is used.
Well, at our end, you're just using one of our cellular routers, and then you just need something that can act as the VPN home at the as the VPN. I guess that will be the server at the far end. I mean, when we've set it up, we typically use Linux boxes. There are different ways of doing it, but you can either have a server that you host yourself, or you can host it remote. You can host it in somebody's cloud setup. Getting into the specifics of how to configure it is probably a bit beyond the scope of this. But certainly if somebody wants to send me an email, then I can happily have somebody talk to you about that.
Okay. And this other question is another question about cloud-based services, and I think we addressed that with Crimson that's to be rolled out coming soon, but they're asking if Red Lion offers any general cloud-based services. Is it just through Crimson, or are there others?
No, I mean, we aren't in the cloud world yet. I think that's, was something more I was describing as our vision of where we see these things going. I think, clearly some of the stuff 6net have been doing, particularly in the cellular side, has been providing those cloud-based management services to people who use their cellular modems, and we've been doing that by virtue of part of our 6net business for years. But I think that's something that we are going to see more and more of, and we'll be looking to add more and more. It's not something that I'm saying you can go buy today, but I think you can see how these technologies drive you in that direction.
Mm-hmm. Now this one is a question about asking if you have any specific software that can provide an analysis of the data that's being collected by your shop floor systems.
No, we're not really in the analysis business. I mean, we see our job as connect, monitor, and control, get that data into those systems. I think there's plenty of people out there who provide excellent predictive management tools or data analysis tools that can look at that data and extract information. I don't think that's ever going to be our core competency, and thus it's not something we would attempt. I mean, we have sister companies who are very much into some of that stuff on the rotating machinery side, but I think there are very good vendors out there. We would look to develop relationships with more of those vendors, I think, because we can provide value to them by providing real-time data for them. But in the end, we're about collecting that data at the shop floor and moving it up to the enterprise. we are not going to provide those analysis tools. We'll get it into an FTP server, we'll get it into SQL, we'll get it into a SCADA system, and we'll help you manage all that infrastructure that's down there. But, you know, I think a man's got to know his limitations, and I don't think that's going to be a world in which we're going to play.
Makes sense. All right. Well, thank you very much, Mike, and thank you all for joining us on this webcast. And if you would like more information from Red Lion on this topic of the connected factory, feel free to visit a special site that they've constructed for this at www.redlion.net/together.